Okay, we're about to do the notes for 11.5, talking about quadratic functions, and we're going to start graphing some of them. So first of all, what is a quadratic function? Well, a quadratic function is something that we graph, and it is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. And a cannot be 0, because if you look, if a was 0, then your x squared would disappear and it would no longer be a quadratic function. It would be a linear function. Okay, so the very simplest quadratic function, I like to call it the parent graph, is f of x equals x squared. And if we were to go ahead and graph f of x equals x squared, it would look something like this. So if I were to plug in 0 for x, 0 squared is 0, so there's a point at the origin. If I were to plug in 1 for x, 1 squared is 1. If I were to plug in 2 for x, 2 squared is 4. If I were to plug in -1 for x, -1 squared is positive 1. And if I were to plug in -2 for x, -2 squared is positive 4. So you can see that that's what my graph would look like. It's a parabola. We already talked about that. And it turns up with its vertex at the origin. So now what we're going to do for the rest of this section is we're going to take that parabola and we are going to learn how to move it around the coordinate axis. So now when all the graphs that we're about to do, you can always make an XY chart. But to do things a little bit faster, I want you to kind of get a pattern in your head. So from the vertex, as long as we don't change the shape of this parabola, from the vertex, you would go to the one right and up 1, and to the right 2 and up 4. Why is that? Because 1 squared is 1 and 2 squared is 4. And you would do the same thing to the left-hand side of the vertex. You would go left 1 and up 1, because again, -1 squared is 1, and you go to the left 2 and up 4. So think of that pattern as we go through and as we learn what we're going to call transformations. So now what if I want to graph f of x equals x squared plus k? What does that do? Well, let's go ahead and let's graph f of x equals x squared plus 2. So if I take and if I make an f of x chart, if I plug in 0 for x, 0 squared is 0 plus 2 is 2. Plugging in 1 is going to give me a 3. Plugging in 2, 2 squared is 4 plus 2 is 6. If I plug in -1, I'm going to get 1 plus 2, which is also 3. Whoops, -1 is going to give me 3. And plugging in -2 is going to give me 6. So let's see what that does to my parent graph that I graphed above. So I'm going to have 0, 2, 1, 3, 2, 1, 2, 3, 4, 5, 6, -1, 3, and -2, 6. So there's the graph. So do you see that what this plus 2 at the end did, or this plus k, is it took my graph and it simply shifted it up 2. So when you have a plus k at the end, or for that case, a minus k, that is what we're going to call a vertical shift. It shifts it either up or down. So hopefully you could do this one without a chart, because you know that this is just going to take our parent graph and shift it down 2. So that means my vertex is going to go down 2 from the origin. Now let's use that relationship we just talked about. I'm going to go to the right 1 and up 1 from the vertex. And then from the vertex, I'm going to go to the right 2 and up 1, 2, 3, 4. From the vertex, I'm going to go left 1 and up 1. From this vertex, I'm going to go left 2 and up 1, 2, 3, 4. And do the best you can to draw that parabola. And you can see that it's the parent graph again, but it's shifted down too. All right, so now let's look at this one. What happens if the shift is within the parentheses? Well, again, for the first one, we're going to go ahead and I want you to see it by making an f of x chart. So we're going to be graphing this one right here. So if I plug in 0, 0 plus 2 is 2 squared is 4. If I plug in 1, I'm going to get 3 squared, which is 9. So I'm just going to start getting bigger and bigger. So I need to go the opposite way, which is -1. If I plug in -1, I get 1. If I plug in -2, you can see I'm going to get 0. If I plug in -3, I'm going to get -1 squared, which is 1. And I'm going to plug in one more value. I'm going to plug in -4. So -4 plus 2 is -2 squared is 4. So let's see what I have going on here. So I have 0, 4. I have 1, 9, which is way up there. I have -1, 1. I have -2, 0. I have -3, 1. And I have -4, 1, 2, 3, 4. So my parabola, as you can see, looks like this. Now let's talk about what that looks like compared to the parent graph. What has happened to the vertex? On the parent graph, it is at the origin. What has happened to this vertex? It's shifted 2 to the left. The shape has not changed. So look what happened here. If it's an x plus 2, it shifted 2 to the left. So you see within the parentheses, it kind of goes the opposite way of what you thought it might. This is a positive 2. You may think that it's going to go to the right 2, but no, it goes to the left 2. So what do you think is going to happen here in x minus 2 quantity squared? It's going to go to the right 2 spaces. So again, let's not plug in points for that. So from our parent graph, this vertex is going to be shifted 2 to the right. So then let's use our going to the right 1 and up 1, and then going to the right 2 and up 4. From the vertex, we're going to go to the left 1 and up 1, and to the left 2 and up 4. And there is the parabola. And you can see that the vertex is shifted 2 to the right. So when it's a vertical shift, it is exactly what it looks like. This was up 2, this was down 2. When it is what we're going to call a horizontal shift, it's the opposite inside the parentheses of what it might look like. So let's use that. Now let's look at another transformation. What happens if the x squared is multiplied by a number out here? So you can see the first one we have is f of x equals 2x squared. So let's go ahead and let's plug in some values. Now you have to be careful here. So if I plug in 0, now don't forget that's 2 times 0 squared. Now you have to do the exponents first, use your order of operations. So 0 squared is 0, times 2 is also 0. If I plug in a 1, 1 squared is 1, times 2 is 2. If I plug in a 2, 2 squared is 4, times 2 is 8. Let's go -1. Plugging in a -1. -1 squared is 1, times 2 is 2. And finally, let's plug in a -2. -2 squared is 4, times 2 is 8. So let's see what that does to our parent graph. So our vertex is 0, 0, so it didn't shift it either horizontally or vertically. 1, 2, and 2, 8, negative 1, 2, and negative 2, 8. If you look, this is the first time where the shape has changed. If you look carefully, this parabola has gotten skinnier. Does everybody see that? We say that it's been vertically stretched because it's gotten skinnier. So instead of going to the right one up 1, we had to go to the right one up 2. So in a sense, its skinniness got multiplied by 2. That's what this 2 does. What if it was a negative 2? Can you take a guess at what that might do? Well, for this one, we are going to do an f of x chart because I want you to be able to see it. Excuse me. So again, 0 is going to give me 0. If I plug in a 1, 1 squared is 1, times negative 2, that's going to be a negative 2. Plugging in a 2, 2 squared is 4, times negative 2 is negative 8. So do you see what's happening on the right-hand side? If I plug in a negative 1, negative 1 squared is 1, times negative 2 is negative 2. And hopefully you see that plugging in negative 2 is going to give me negative 8. And if I plot those points, you can see 0, 0, 1, negative 2, 2, negative 8, negative 1, negative 2, and negative 2, negative 8. So it's the same shape as the first one. It's still skinnier by a multiple of 2. But because that 2 is negative, it's going to turn down. So the 2 and the negative actually do different things. The 2 changes its shape, makes it skinnier. The negative makes it reflect over the x-axis. All right, so let's put that all together and let's go ahead and let's do this example. Look at everything that's happening. So we're not going to make a chart for this. Let's see if we can put everything together that we know. So let's talk about our vertex. Now remember in the parent graph, it's at 0, 0. Well, we know that this is a shift of 2 to the right, and this is a vertical shift of up 3. So do you see that our vertex went from 0, 0 to the right 2, and up 3, our new vertex is at 2, 3. Okay, so that takes care of both of these shifts. Now, what does the negative 2 do? Well, the 2 is going to make it skinnier. The negative will turn it upside down. So if we could use a chart if we wanted to, or we could just realize that if I, from this vertex, go to the right one, I'm going to go down 2. And if I go to the left one, I'm going to go down 2. And then just like the one above, if I go to the right 2, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. So twice the 4 that I would do without the 2. And then I can do the matching point over here. And there's your graph. So we've done all the shifting of parabolas.